Okay, what's the answer to 22?
C.
No. Those are the ones that we're going to study, but they're not the population they mean to represent. That's the sample. C would be the sample. What would be the, but I appreciate you trying. I don't want to discourage you just guessing, but
La letra.
uh,
La A.
no.
It will be all Americans.
B, all Americans. So we want to, so yeah, there's a lot of terms in there, but what are we trying to say? We're asking Americans whether they have a favorable opinion of Canadians. So all your answers, I can see why you're thinking that way. However, we are interested in Americans' opinions. So we're going to study Americans. We're going to take a sample from all the American states with the idea to represent all Americans. So B is the answer. Okay. The population of interest, population, meaning we're going to get a sample. The sample is meant to represent the population. Okay, what about 23?
That's C.
What does everybody else think?
A.
So the key thing to look at is here. A simple random sample, oops, of 20 people was contacted from each of the 50 American states. So they made a simple random sample within the state. They stratified by state. They wanted to include every state. So Lucero is correct. It's A, right? You said A?
Yes. Yes, I said A.
Good. Good. You want me to look for another one? So any questions about that? Okay, let's try. Anyway, let's just try some of these. Let's continue. Let's continue. What about this one? So you need to go back to the definition of simple random sample. What is a simple random sample? Go back into your notes and see what it is. Hey, is it no or yes, first of all? Is it a simple random sample? Let's look at the definition of simple random sample. It's on page 17. Here's the definition of simple random sample. Does that help you? So the first question is it yes or no? And then we'll pick between the options left. It's process of elimination. Ready? So yes or no? Is it a simple random sample? So what we're going to do that says here, he selects a sample of 50 professors by randomly, selecting 10 biologists. So he goes in the biology group and he labels them 01, 02, 03, 04, all the way to 40, and he selects 10 from there. Then he goes into the chemistry group and he selects, he labels 01, 02, all the way to 20. And he picks 5 chemists. Then he goes to computer science, 01, 02, all the way to 40, and he picks 10 computer scientists and so on. Is that a simple random sample? No, it is not a simple random sample. It's a sort of stratified sample with simple random sampling inside each strata. Okay, so it's not a simple random sample. So no is the answer. Now you have to pick between B and C and E. Which is the best answer? So each biology professor has an equal chance of being selected. Each chemistry professor has an equal chance of being selected. Each computer science has an equal chance of being selected, but between them, it's not the same chance. Who has the best chance of being selected? Which department? Do the professors have the best chance?
Math.
When there's less people in it, right? So in chemistry, your chance is 1 out of 20, and in physics, your chance is 1 out of 20. Oh, and statistics. So those 3 have more of a chance. But if you're in a biology department with 40 people, is your chance better or worse? It's smaller, so it's not as good. It's a less chance, lower chance. So overall, they all have a different chance of being selected. And if I was to think of all possible combinations of the biology, the chemistry, and all these professors, every possible sample of 50% professors do not have an equal chance of being selected. That's the best answer. So no is part of the answer. The explanation, though, is that each sample of professors has a different chance of being selected because some professors are different departments and they have different chance. Okay, don't worry, I won't ask you that. That's a little more challenging, but I want you to think about this is not a simple random sample. That's the main thing I want you to get out of this. Yes, there's simple random sample inside the strata, inside each group, inside each department, but not overall. Okay, so it's not simple random sample. If you guys can get that out of that question, that is great. You want to try this one, or it looks too wordy? Let's try something. Oh, everyone is wordy. That's the problem with this unit. There's a lot of words. I don't know. It's too wordy. Try 27. It's wordy, but it's not too many parts. Okay, so which terms do you not understand? How many factors in this experiment?
I think letter E.
Well, okay, just one sec. How many factors are there? What's a factor? Go back and read. What is a factor? If you need to.
I think it's like red, blue, yellow, top shelf, middle shelf, bottom shelf.
Okay, so color of the box. So it's like, what were the factors in the physician health study? It was beta carotene, it was aspirin. There were two factors. And each factor had two levels. And I'm asking you for the factor levels. So the two factors are color of the box and shelf placement. We don't need a control group because this is not about humans. This is about cereal, okay? So we have the color of the box as one factor and the shelf placement as a second factor. But the factor has levels. 3 levels for color and 1, 2, 3 levels for shelf placement, right? So there's 6 levels. Sorry, 6, no, it's 3 times 3. So to find the number of treatments, right? So factor levels would be right, like it's the number of treatments. And how did I teach you to do the number of treatments? You have to take the levels of the first 3 times the levels of the second 3, and that's 9 treatments. So which is the answer? Again, Lucero?
Lie. Letter E.
Lie. Okay. Anybody dispute or confused? And we did this in 180 American stores and 90 Canadian stores. But the factors are the same in Canada, the factors are the same in the US, and the levels are the same. One second. So you guys seem to be having difficulty. You need to review before next week. I'm trying to give you different problems so that you to preserve the ones you have. Like, that's why I'm showing you these different problems. Okay. Okay, I'm going to clarify something about 27 that we just looked at. So we're going to be clear from here on out because there's confusion. All right, so factor levels are not the same as treatment, okay? Treatment is when you take 3 and one factor with 3 levels times one factor, another factor with 3 levels, 3 times 3 is 9. That's treatments. Factor levels are just the levels of the factor. It's different. So what would you say to that answer or that explanation? Those are the 6 levels. 3 here and 3 here, 6 levels, okay? If I asked for treatments, then you would say E. The different combinations, like we made the table, and I explained in the video that I made that there are 9 treatments for the baking experiment. Did you guys see that? No? Yes? I explained that you get 9 because it's going to be 3 times 3, and I explained how you can see 3. Or in the baking experiment, it wasn't 9, it was 18. And I showed how to get 18. So yeah, that's in the video, the videos that I provide. Yeah, you guys can't just come to class and I'm going to teach you everything. You have to do the homework. It's not going to be like that. Any questions about 27? Should I do some more before I go to unit 2? It's almost 7 o'clock. So you can take a screenshot or you can watch the video later. It'll be in there. I don't know if you notice, I'm putting the recorded videos onto Moodle within the unit. So you can find it. So this, I'll put this up. Since this is a review of unit 1, I'll put it up in unit 1. Maybe I'll stop the video and start again when I go to unit 2, so I don't have to edit. I'll just have a new video. Another one? Yes, no? you want another one, Natalia? No more? You're done? Sergio, do you want another one? Okay, so we're going to go to unit 2. So I'm going to stop videotaping and then I'll start a new one.